2. So I find my vertex 1, 2, 3, 4. Then I go down 1, 2, 3, like this. Since I know the graph has a positive 2, I know the graph's going to open upwards like a happy face. But since it's stretched by 2, you have to be careful here. I start with my vertex. Normally I'd go over 1, up 1. Because it's 2, I'm going to go over 1, up 2. Since it's a 2, I normally go over 2, up 4, but I'm going to have to go over 2, up. 4 times 2 gives me 8. So 1, 2, 3, 4, 5, 6, 7, 8. So I can reflect it on the other side now. So we have something that looks like that. The next one would be over 1, 2, 3, up 9 normally, but because we have the 2, it needs to go up 18, and that's not going to fit over there. But imagine where the 18 would be, right? It would be kind of like, let's say somewhere maybe up like that and that. I have students that sometimes do this, and I don't want you to. They kind of get to here, and then it just kind of goes wide like that, right? It needs to be realistic, all right? So not kind of crazy off like that. Instead, right, imagine where that next point would be. Well, you need to make sure you basically stay inside of that line right there, right? Because it shouldn't be crossing that yet. So stay inside of it, all right? And the rest you can just kind of estimate, but stay inside of it. Don't get too wide, all right? Okay. Last example I have for you is kind of going backwards. I'm giving you a graph, and now I want you to find out what the equation of this one is. So remember that the format is y is equal to a onto x minus p all squared plus q. That's how you're going to answer this. So instead of this lovely blue graph, we're going to be trying to figure out what all this a, p, and q stuff is. So I'll fill in all this. This stuff's going to be standard. Let's start with my vertex. So if you look at this vertex right here, I see it's right down there. It's moved 1 over in the negative direction. So remember, that's always the opposite, so I know it's going to be x plus 1. How much has it moved downward? It looks like it's moved down 8, so I'm going to have minus 8. And now I need to see, has this graph been stretched or compressed? Well, normally the graph would go over 1, up 1, over 2, up 4. But this one, if you look, it goes over 1, up 2. So it looks like it's been stretched by a factor of 2. Let's just double check. The next one would be over 1, 2, up 4. It's going up 8. Yep. So we know that the factor of a is going to be 2. The graph has been stretched by a factor of 2. All right. So that concludes this lesson. We now know what a, p, and q do with the graph. The q is going to move it up or down. The p is going to move it left or right. Always remember that that one's kind of opposite. So when you see a negative p, actually move it in the positive direction. If you see a positive, move it in the negative direction. And a, we know 2 things about it. If a is positive, it's going to open up. If a is negative, it's going to open down. If a is a number greater than 1, it's going to be stretched. If a is a number less than negative 1, it's also going to be stretched. If a is a number between positive 1 and negative 1, it will be compressed.